Okay, so we're going to be looking at derivatives with the power rule today. So to start, we're going to look at this graph and estimate the slope of the tangent line at the indicated values. So I'm going to start and look at x equals 1. So what I'm going to do is go to my graph and plot a point at x equals 1. And I want to sketch a line that would roughly follow the slope at that point. So about right there. Okay, and we're just going to be estimating these slopes. So I'm going to put a little estimation here. Well, if I'm estimating the slope here, that rise over run is about 2. So at x equals 1, it's about 2 for the slope. Going to 2.5, if I go to 2.5, I'm sitting right there, which we saw this in our previous unit, but at the top of a parabola, the slope is 0. And then at x equals -3, if I extend that there, we are looking at about -5. Okay, and so those are about the slopes at those different x values. We're now going to find the derivative using the power rule. So how we're going to do this is, first of all, the derivative notation, f prime of x equals, I'm going to take this exponent and multiply it with the coefficient out front. So I brought this out front and multiplied it with the 3, and then I take that exponent and subtract 1. So simplifying this, that's 6x, because 3 times 2 is 6, and then 2 minus 1 is just 1. So there is the derivative of that. Looking at this one, we can apply that power rule to each term here. So starting with x cubed, I bring that 3 and multiply it with the coefficient of 1, and then I subtract 1 from 3, which leaves me with an exponent of 2. For the second term, I'm going to bring this 2 out front and multiply it with the 3, which leaves me with 6. And then I have x, I subtract 1 from that, so that's just the first degree. Here, that's an understood 1. When I multiply it with the 2, it just stays 2. When I subtract 1, that becomes x to the 0 power, which is just 1. So this is just going to stay 2. And then -1, the derivative of a constant is just 0. So we don't do that, that just turns to 0. So the derivative of f of x is 3x squared minus 6x plus 2. Okay, for these next two examples, we just talked about how the derivative of a constant was 0. So if I take the derivative of this, that is just 0. For this fraction, I need to rewrite this so it's x to the -2. I don't want to use the power rule if I have that x in the denominator. I'm going to bring this out front. So 6 times -2 is -12. And then if I subtract 1 from that, that's x to the -3. When we write our final answer, we don't want negative exponents. So I'm going to put that x to the -3 in the denominator. Okay, I'm going to do the same thing with this term right here. I am going to rewrite it with a negative exponent. And then I'm going to go term by term. So I'm going to bring the 2 out front here, so that becomes 2x, and when I minus 1 is just the first degree. This is just going to become 1. -3 times -3 is 9. And then minus 1, we have x to the -4. And I'm just going to put that negative exponent back in the denominator. Okay, so when we talk about the derivative, that helps us find the slope. So this says find the slope of the graph y equals x plus 1 over x at x equals 2. So I need to find the derivative of this and then plug in 2. So to start, I'm going to rewrite that 1 over x to x to the negative 1. Find the derivative. So the derivative of x is just 1. Here I bring that negative 1 out front, and then it's x to the negative 2. So this is going to be like that. So then I use my derivative to find the slope. I plug in 2 for x. And so this is 1 minus 1/4, which is 3/4. So the slope is equal to 3/4 at x equals 2. Okay, now we're going to write the equation of the tangent line to this function at x equals negative 1. To write the equation of the tangent line, we're going to put it in point-slope form. So I need my point and I need the slope. I know the x value of my point, but I need to find the y value. So to find the y value, I'm going to plug in negative 1 into the original function. So this becomes 3 divided by negative 1 cubed is negative 1. So that turns to negative 3 plus 1, which is negative 2. So there's the point I'm going to use. To find my slope, we have to take the derivative of this. So let me rewrite this with that negative exponent. And so I take the derivative. So this becomes negative 9x minus to the negative 4, so by minus 1 from that. The derivative of a constant is just 0. So then my derivative, I can just plug in negative 1 here, and that'll give me my slope. So negative 1 to the 4th is just 1. Negative 9 divided by 1 is negative 9. So I now have my point and my slope. I say y minus y1, which is going to become plus 2, equals negative 9 times x minus x1, which is going to turn to plus 1. There's the equation of my tangent line.